Hello guys, welcome back to our channel, and today in this video we are going to continue the discussion about the graphs of motion. Alright, so for now we are going to discuss the velocity time graph. So as usual, we need the graph, so therefore we prepare our GeoGebra to help us in graphing um, velocity versus time. Alright, so we put in mind that the velocity is plotted in the y-axis and time is plotted along the x-axis. And then so we have our channel here, and you see that we have a lot of videos here you can actually check. We post a lot of contents, and hope you to visit it so that you can gain more knowledge, and it will help you more in your studies. So I think I can simultaneously present the screen because I have two screens. Alright, so right here on my left, which is the GeoGebra. Okay, so on my right is where the lectures are being written, but I can actually do a freehand on GeoGebra. So you go guys and download GeoGebra. Okay, so here um, this one gives us the acceleration. All right, because if there is a change in velocity, there is always acceleration. So the thing is, it can be positive or negative. So the uh, negative acceleration, okay, positive acceleration and negative acceleration. So these signs can be due to the change in direction, or relative change in direction, or relative change in magnitude. Alright, so you put that in mind. Change in magnitude. So this will be slide 1 for physics. Okay, so slide 1, physics, um, 11, 13, 22. So that is the day today, and then I have to save it in one folder. Oh my god, didn't save it. No, no, no. Alright, so that slide's gone by. Okay, but anyway, we have recorded it, so don't worry. And to start with, alright, so let's have a graph. So we have two versions, one in the paint and one in, okay, the GeoGebra. Alright, so that's straight, and then moving on, so this is slide 2, so this is velocity, okay, and then this is time. Alright, so time always flow in one direction, it never runs backwards, so um, it can be infinite. Alright, but here is a mistake that velocity is infinite. Okay, so there is a limit, and according to Einstein, the speed limit in the universe is the speed of light. So there is a limit for that. So let's say, for example, we have the graph of velocity here. Okay, so this is 1 meter per second, then 2 meters per second, 3 meters per second, 4 meters per second, and then so time 1 second, 2 seconds, 3 seconds. Then I think I can use the red ones, or for this, why not? 5s, then so on and so forth. Alright, so the only problem with GeoGebra is that I think you cannot change the pen color, or well, I don't know. So let's say, for example, let's graph it. Let's say, for example, you're moving after 1 second, you have moved 1 meter per second, so that's it. And then afterwards, you increase. Okay, you stop. When you say you stop, time passed by, but you stop. All right. So here, so you can actually connect this, and then after that, you after 5 seconds, you run away because you saw a snake, and then you get faster. All right. So there is a change in velocity. So you can get the change in velocity as delta v, all right, is equivalent to v sub I, or v sub f minus v sub I, all over the time interval t sub final minus t sub initial. So this is actually the uh, acceleration. Okay, so I think I have to erase that, and then that's actually the acceleration. Hmm. That's A. So well, eventually I am going to um, make some slide presentation of this. So this is just my template and the upcoming video. Alright, so you will see that it accelerated because there is a change in the magnitude. Okay, you stop and then you go, so you go faster. So when there's something like that happening, there is an acceleration. And the good thing here is the area. Okay, the area under the figure. Okay, so this thing under the figure, let's say for example you start from here. Well, you start from 0, right? Yep, you start from 0 and then you accelerated. There's a change in velocity. Alright, so this area here plus this area right here, okay, so this area um, gives the total distance traveled. Alright, so the area under the figure, or under the curve, so sometimes it's a curve, uh, yeah, so you can see that there is a curve right there. Then uh, gives us, or sums up, the total distance traveled. Okay, so you can actually see that we have a triangle right here. Then you have to compute for the area of the triangle. So this one is a right angle. So you have 1/2 base times height. Okay. So this is the base, and then this is the height. Then you multiply the two together, and then you add, and then here. So you get the total distance traveled. So this illustration is not accurate. So we're going to move to um, GeoGebra app so that we can uh, solve for that. Okay, so let's do it. So I'm gonna add now a point since we know that you started from rest. Okay, then say for example you move from your original position, and then you have gained the velocity to 1 meter per second. So um, that's where you are, or that's your velocity. Oh, then I'm gonna use a line segment to connect the dots or the points, and then afterward you stop, so time passes by. Then you decelerate, of course. So again here, your velocity is 0 meters per second. We're going to connect that. And then as I've mentioned, you accelerated. So let's say for example, after 7 seconds, okay, for that I can actually have space. So after 7 seconds, your velocity now is 5 meters per second. So here, let me go freehand. Okay, or can we, or can I? Oh, I can't. Alright, so this is, okay, so let's interchange it. Why not? Okay, so that I can make use of my stylus. Alright, so this is where velocity is plotted. So this is velocity. And then we have here time. Alright, so we say that the area under the figure is actually the um, total distance traveled. So we want to close this figure, alright, and then do it like this, and then this is the total area under the figure, and then we want to find the area, right? So how do we do that? So for the triangle, we see that it's actually 1/2 base times height, and for the big triangle here, we have um, 7 minus 2 for the base. Okay, so that's gonna be 7 minus 2 for the base, and then the height will be 5. Why 5? Because 5 minus 0. Alright, all over 2. So this one is 5 times 5 divided by 2 is 25 over 2, that's 12.5. Divided by 2 is 6.025. So this is 6.025 meters. And then here are two small triangles, each having a leg of 1 and a height of 1. So I'm gonna say 2 because we have two triangles which are symmetrical, times 1/2 base times height. Alright, so that's 2 So that's base times height. So we have y because we can cancel this one out. So the base is 1 by 1. So 1 meters. Okay. So you add it plus 1. So that's 7.025 meters. So that's the total distance traveled. Okay, that's how we compute for the total distance traveled if we are given the velocity versus time graph. Okay, so this is the part of the video. This is it. So I'm going to upload it and then um, subscribe so that you will follow.